So letter C, what is the area of the logo? Explain your reasoning, write an equation to model the problem. So basically, we would just turn those into what? Well, basically, to figure it out, you know there's how many here in this one whole thing? This would be 1, right? This would be what? 5 10, right? Okay. This would be 4 10. And this would be what? 8 10, right? So 1 plus 5 10 plus 8 10 plus 4 10. Okay. So that would equal 1 and 5 plus 8 plus 4 is what, guys? 17. Okay. 17 10. Which equals 2 and 7 tenths. And then inches squared. Okay, so that's just like the quadrant that we have done before, right? Okay, except for in this case they were shaded. All right. So rename 1 and 1/2 and 1 4/5 is a greater as fractions greater than 1. So these we need to make into improper fractions. So it would be our equation that we've been doing, right? Okay, so we would write it as 1 and 1/2 times 1 and 4/5. Okay, multiplication sign, plus sign, multiplication sign, plus sign. So 2 times 1 is what? 2 plus 1 is 3. So 3/2 times, okay, work around the clock, right? Start at the bottom. 5 times 1 is plus 4 is 9. So 9 fifths. Can I simplify before I start? No. So 27 tenths, right? Which equals 2 and 7 tenths. So does this match that? Okay. So that was 2 different ways that we could do it, correct? Okay. So use your answers from part D to write an equation to model the area. So we did do that, right? So it was 1 and 1/2 times 1 and 4/5 equals the area, correct? Jonah's new poster has a width of 1 1/4 yards and a length of 1 1/3 yards. Use the area model to represent the area of the poster. Okay, so they want us to find the area of the poster that way, and then they also want us to come up with an equation like we did over here with improper fractions, okay, that are greater than 1. So we are going to break apart 1 1/4, so 1 here and 1/4 here, correct? Okay. Then how am I going to break apart 1 and 1/3? 1 and then the 1/3 here, correct? Okay. So the thing is that you're going to have to write kind of small to do your work in there. I can't technically do that because I can't on the board. So what I'm going to write over here to the side, you're writing in the box. Does that make sense? Okay. So this box would be what? 1 times 1, right? Which equals 1. Okay. This box right here would be 1 times 1/4, right? And anything times 1 is itself. So our answer is 1/4. Okay. This box right here is 1/3 times 1, which equals 1/3. Okay. This box right here is 1/3 times 1/4, which equals 1/12. So what's my common denominator? 12. So this would be 3/12, and this would be 4/12, correct? Okay. So now what do I do with all of them? I need to add them. Okay. So 1 plus 3/12 plus 4/12 plus 1/12 equals 1 and 8/12, which also equals Okay, what goes into both of those? 4, right? So 1 and 2/3 yards squared. Okay, now what they also want us to do is they want us to write an equation where we convert. So we would have 1 and 1/4 times 1 and 1/3. So they want us to convert that into an equation that has fractions larger than or greater than 1. Okay, so we call those improper fractions, right? Okay, so multiplication plus sign, multiplication plus sign. We're converting our mixed number to improper fractions. So we need to work around the clock, starting at the bottom. So 4 times 1 is, plus 1 is 5. So 5/4 times 3 times 1 is 3, plus 1 is 4. So 4/3. And they just wanted that equation. So that was all we needed for the second part. On your own, your structure, the flagpole at a park is 3 1/3 yards tall. The flagpole at a museum is 1 1/2 times as tall as the height of the flagpole at the park. Explain how to write an equation to model the height of the museum's flagpole. So, what will be our equation? Our original starting one. So we have this, and we have this. Okay, so we're going to take 3 1/3 times 1 1/2, and then we can convert that into a what? Improper fraction, or fractions greater than 1. Okay, so I'm going to put my little multiplication plus sign. Then I'm going to work around the clock, starting at the bottom. Okay, so 3 times 3 is 9, plus 1 is 10, so 10/3 times 2 times 1 is 2, plus 1 is 3. So 3/2. Can I simplify before I start? Yes, so 3 can go into 3 one time, right? 2 can go into 10. So 2 goes into 2 one time. 2 goes into 10 5 times. So our answer is 5/1, which equals 5. So what is the height of the museum's flagpole? 5 yards. Now, is this yard square? No, because they didn't want the area. They just wanted to know how tall it was, right? Okay, so number 3, model with mathematics. Debbie measures the length and width of a cell phone. The length is 5 3/5 inches, and the width is 2 4/5 inches. What is the area of the front of a cell phone? Write an equation using fractions greater than 1 to model the problem. So this one, do they want our quadrant? No, they just want us to convert our mixed numbers to improper fractions, right? So we would do the 5 3/5 times 2 4/5, and then I need to make these into improper fractions, so I put my what? Multiplication plus sign. So work around the clock, starting at the bottom. 5 times 5 is, plus 3 is 28. So 28 times, work around the clock, starting at the bottom. 4 times 2 is 10, plus 4 is 14. So 14 fifths. Okay, now can I simplify that before I start? No. So my number is going to get pretty big, right? Okay, so let's see what 28 times 14 is. So 4 times 8 is 32. 4 times 2 is 8, plus 3 is 11. Mark off my 3, mark off my 4, and put a 0. 1 times 8 is 8. 1 times 2 is 2. And then add. So 2, 9, 3. So 392 over 25. Okay, now this is 25 is like a quarter, right? How many times can 25 go into 392. So 4 quarters get us 100, right? Yes. So that's at least going to be 12, and then add 3 more, so 15. And that gets me 375, right? Okay. So what is 75 minus 90, or 92 minus 75? 13. No. 17 25. So our answer would be 15 and 17 25th inches squared. Okay? So on these next ones, they want you to convert them into improper fractions and then get your answers. Okay? So multiplication plus sign, multiplication plus sign. Work around the clock. 5 times 2 is 10 plus 1 is, so it would be 11 fifths times 2 times 3 is, plus 1 is 7 halves. Can I simplify? Nope. So 77 tenths, which equals 7 and 7 tenths. Okay, and I'm going to work over to the side because I can't get that small. Okay? All right. So multiplication plus sign. So work around the clock, starting at the bottom. 2 times 5 is 10, plus 1 is 11. So 11 halves again. Not again, but this time. Okay, so 11 halves, and then 3 times 1 is, plus 1 is 4/3 equals, can I simplify before I start? Yep. Yes. So 2 goes into 2 once, 2 goes into 4 twice. So that gets us 22/3, which equals 7 and 1/3. 7 times 3 is 21, and then 22 minus 21 is 1, and then we keep our same denominator. So 7 and 1/3. Okay? Multiplication plus sign, multiplication plus sign. So 4 times 2 is 8 plus 1 is 9. So 9/4 times 3 times 1 is, plus 2 is 5. So 5/3. Can I simplify before I start? Yes. Yes. 3 goes into 3 1 time. 3 goes into 9 3 times. So 15/4, which equals 3 and 3/4. An early computer connection called USB 1.0 transfers about 1.5 megabytes of data each second. A later connection called USB 2.0 transfers data 40.5 times as fast as the speed of the USB 1.0. How many megabytes can a USB 2.0 connection transfer each second? So we have 1 in the 1/2, 40 in the 1/2. So multiplication plus sign. So this becomes 3/2 times multiplication plus sign. This becomes what? 81/2. Can I simplify before I start? No. So this would be 3, that's 243, right? Over 4. So over here, I can take 243 divided by 4. 4 goes into 24 6 times, minus 24. Bring down the 3. 4 can't go into 3, so it goes 0, minus 0, with 3 left over. So my answer is 60 3/4 megabytes.